Alright guys and gals, this video is to help you out with the practice test since I won't be here. I'm going to walk through each problem. I'm going to go through some of them kind of quickly, so get your pencils out. Here we go. Alright, first question here in this Laws of Exponents section. Which equation is true? So let's look at each answer and see what we think. Top one can't possibly be true. If we're taking things to a power, we're not adding, we're multiplying, so that one can't possibly be right. If that's the case, then it means C can't possibly be right. Remember, anytime we're taking a number to a power, we are multiplying. So that leaves either B or D. Notice this base is 4, but if we look here, the bases that are being written out are 7, so that can't possibly be right. Let's look at this one. Base is 2, the numbers are 2, so that looks good. We're told we're supposed to have 5 of them. 1, 2, 3, 4, 5, all multiplied together, so our first answer here is D. All right, let's look at the next one here, number 2. A bakery sells muffins in boxes of 12 each, so that seems important. 12 different restaurants each of them order 12 boxes of muffins every morning. Which expression shows the number of muffins the bakery needs to fill the order for 12 days? Well, let's think about it. If there are 12 muffins in a box, and there are 12 boxes, we'd have to multiply by 12. For 12 different restaurants, yet another multiplication of 12. Over the course of 12 days, yet another multiplication of 12. I have 1, 2, 3, 4 different 12s all being multiplied together, so we can represent it this way. So take a look. This first answer makes absolutely no sense. We're not in base 2. This answer makes no sense. We're not in base 4. We aren't taking it to the 12th power. We only had 4 of them, so B is the only answer that works. D doesn't work either. So again, it helps if you can eliminate things. Let's try number 3. Emily evaluates the cube of -8 multiplied by the square of -8. So let's underline some things here. The cube of -8, the square of -8. And we're told that those are multiplied together. How is this written, and then how is this simplified? All right, well, it helps sometimes if you can come up with your own answer. So if I were to work this out, the cube of -8, I would write it this way. -8 to the 3rd power. Again, it says the cube of -8, not the cube of 8 and then make it negative. So we need those parentheses. Also, it says the square of -8. So let's do that. Not -8 squared. So that's how those would be written. Notice we're multiplying them together. So we'll write it like this. So let's see what we've got. C and D can't possibly work. They don't have parentheses. So it's between A and B, and it looks like their setup to ours looks exactly the same. So now it's a matter of simplifying it. Well, if I'm multiplying powers with a common base, I just simply add the exponents. So in this case, I'll have -8 to the 5th. That looks like A, so B doesn't work either. All right, let's try the next one. Excuse me. Which shows the expression below written in exponential notation? All right, so in other words, which of these below here actually shows everything all multiplied out correctly? And notice it says exponential, so I want exponents. So let's see here. Notice I only have 1, 2, so let's write it down. So we only have 1, 2. Multiplied by, let's see here, I've got 1, 2, 3, 4 3s. So 3 to the 4th. All right, multiplied by, let's see, I've got 1, 2, 3 5s, so that's 5 cubed or 5 to the 3rd. So let's see here, which answers look like it works. Well, it looks like A is the only one that matches what we have. Notice in this case, not going to work. Notice we've got this 9 squared, which, no, not what we were dealing with. We've got our bases here. Not sure where this 10 came from. And then again, this 81 and 125, again, that might be what these work out to be, but it's not in the correct exponential form. So A is what we're going for. All right, move it up. Let's try 5. It says, which numerical expression is equivalent to, let's see, what is this? 5,230 and, let's see, that's tenths, hundreds, thousandths, and 7,000ths. All right, well, let's see what we've got here. This first number, 5, is in the thousands position. So that would be 5 times 10 to the 3rd. So notice A and B only have it to the 2nd. We can cross those out. Well, let's notice about C and D. 5 times 10 to the third, 2 times 10 to the second, so those are the same. 3 times 10 to the first, so all of the rest of this, so I'm just going to write this out as plus dot 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 because all of the rest of it doesn't matter. Plus, we need to figure out the 7 bit. So 7 times 10, let's see here. We'd have to go 1, 2, 3 spots back to the negative third. Notice this one only has 10 to the 0. We don't need it. C is the correct answer. All right. Next page. All right, let's see here. More laws of exponents. Matt's teacher asked the class what to do when multiplying the expression 4 to the third, 4 to the fourth. So which of the following is correct? So let's say it says you keep the base the same and add the exponents. Well, that seems to have merit. Let's hold on to it. You keep the base the same and multiply the exponents. Well, notice we're taking and multiplying powers of a common base, so we're not going to multiply the exponents. That can't possibly be right. You multiply the bases and add the exponents. Well, we know bases stay the same, so that can't possibly be right. Let's see here. You multiply the bases and multiply the exponents, which that one's just completely ridiculous. We've never done anything like that. It has to be A. Okay. Let's try the next one. To simplify the following expression correctly, what must be done with the exponents? So notice in this case, I've got an exponent A, exponent B. What would I do with them if they were numbers? So it says add, subtract, multiply, or divide. Well, first off, we have never divided exponents like that, so that's out. So it's either add, subtract, multiply, or divide. Well, I remember that if we're subtracting exponents, in this case, we would be in a division problem. There is no division, so that can't be right. If we're adding exponents, we just said it would look like this situation that we just worked up here. Well, these don't look the same, so that can't be right. So if I look here, multiply the exponents, and that's what you do. We would multiply A times B, whatever those numbers are, to get our answer. So C is where we'd want. Good. Number 8. Which of the following is equivalent to all this mess worked out? All right, well, let's work through it. 4 and 3 here, we would have to multiply together. So let's rewrite it. So this would be P, let's see here, what would this be? To the 12th, once we multiply, over P, let's see, to the 2nd. All right. Well, we're dividing here with common bases, so let's subtract 12 minus 2, so that would be P to the 10th. There it is. The rest of them, we couldn't care less. So we got our own answer. It matches. We're good. All right, let's try the next one. Which represents the expression written out there in simplest form? So let's look. First, let's deal with the x's. I would take 7 and 3, and we would have to subtract those. We'll write our answer here. Let's see, that would be x to the 4th power written in the numerator. Well, let's look. No x to the 4th in the numerator, so that can't be right. No x to the 4th in the numerator, that can't be right. Again, no x to the 4th in the numerator, that can't be right. Looks like B is all that's left. And if we notice that y to the 3rd, that's what you would get here. 2 minus 5 would be y to the negative 3rd, which we rewrite in the denominator. All right, well, there's number 9. That one was pretty easy, too. All right, let's try number 10. Simplify the following expression. So let's see here. We're multiplying with common bases. So let's see what we get. Let's first take our 6 times our 2. Those are coefficients, I guess you could call them. They're also constants. They don't have common bases to work with, so we're actually going to multiply them out. So 2 times 6 is 12. So 12 had better start off our answer. We'll notice C and D start in 12. A and B don't. We don't need A and B. All right, well, let's take a look at x's. I've got x to the 1st. I'm going to write that in there. And x to the 2nd. We'll add the exponents. So 1 plus 2 is 3. So x to the 3rd. Let's look at our answers. D has x to the 3rd. So that means C shouldn't work. Now, if we look at the y's, they should be to the 3rd as well. So let's see. Y to the 1st, y to the 2nd. Sure enough, y to the 3rd. So we have a good answer. All right. On we go. This test isn't going to be too difficult. Laws of exponents continued. Goodness gracious, how many more do we have? All right, now I don't like questions like this as a kid, but as a teacher I sure do like them because they mess you all up. Which is not equivalent to this? So in other words, let's look for all of the ones that are equivalent and mark them out because I want the one that is not equivalent. So I've got 10 to the negative 3rd. So how many different ways can I write that? Well, I noticed it's a negative exponent. Let's go ahead and write it so it has a positive exponent. So I'd write it as a fraction. 1 over 10 to the 3rd. So this and this new version, they're the same. We'll look down here. There's A. I want what's not equal, so let's mark it out. All right, well, we could take this 10 to the third and expand it, right? So let's see, 1 over, if I took 10 times 10, that's 100, times another 10, that's 1,000. Well, sure enough, there's B, 1 over 1,000. So that's equal. We don't want that either. How would I read this number? 1,000th. Well, sure enough, there's 1,000th. There's Z. I don't want that either. Well, let's look at C. I've got tenths, hundredths. This right here, this last 0, is the thousands position. So this number is actually read 1/10,000. This is not equal. So that is the one I want. In this case, the question asked what's not equal, and that's not equal. All right, number 12. Let's see if we can scoot it up here so we can see it. Which expression is equivalent to, let's see, what do we got there? X to the fourth multiplied by the square of x to the negative 6th power. Goodness, that one's kind of nasty. Well, let's see what we could do. First off, we know we got to multiply these exponents. We're taking powers of powers, so let's multiply the negative 6 and the 2. So we'll have x to the fourth multiplied by x. Negative 6 times 2 is negative 12. And notice we still have more work to do, so let's keep going. Let's see, 4 and negative 12. Notice we got common bases here, so we'll add those together. So x, let's see, 4 added to a negative 12, that looks like a negative 8 to me. Can't keep it that way. Notice we have no x to the negative 8 here, so we're going to have to keep working. With a negative exponent, remember, it goes to a denominator. So we could write this as 1 over x to the 8th. Notice we don't have anything to write in our numerator, so we're going to put a 1 there just to give us something to write. Well, as I look at my answers, the only thing up here that seems to make sense is B. It's the only one that matches, so A, C, and D are just out of luck. All right, keep going. Excuse me, number 13. Which expression is equivalent to all this nonsense? All right, well, let's work it out. So notice this is 4 minus negative 3. Let me write that out there. 4 minus negative 3. Remember, we subtract our exponents when we've got common bases and we're dividing. Add a line, change a sign. So that looks like 3 to the 7th power multiplied by 3 to the 2nd. All right, so we're multiplying powers there with common bases. Means we add the exponents. So this should be 3 to the 9th power. All right, well, that looks like choice C, which makes D, A, and B also out of luck. Well, this isn't so bad. This is pretty easy. Well, let's keep going. Which expression is equivalent to what we see here? All right, well, let's see what we've got. First off, I notice I've got this 10 to the 0 business. 10 to the 0 is just 1. And 6 to the 4th times 1 is just 6 to the 4th. So let's rewrite this. So I know this is equal to 7 to the 2nd over 6 to the 4th. All right, there's no need in writing times 1. That's just silly. Well, let's look. None of my answers at this point seem to match. But I do notice something. This 7 to the 2nd is in a numerator, meaning it's a positive exponent. B has 7 to the 2nd, so let's hold on to it. We'll hold on to it for the time being. This has 7 to the 2nd, but notice it's in a denominator, implying that it's negative. Well, that doesn't work, so let's mark that out. 7 to the 2nd, positive, so let's hold on to it for the time being. And 7 to the 2nd, positive, so we'll hold on to that one as well. All right. Well, let's look down here. This 6 to the 4th business. Well, I noticed that B doesn't have 6 to the 4th anywhere, positive or negative, and we can't just get rid of it. So B turns out it's a bad answer. Let's forget it. I've got a 6 to the 4th here and a 6 to the negative 4th here. So the question is, which one is which? Well, notice if I took this and wanted to rewrite it so that it is without a fraction or division sign here, I could write it as 7 to the 2nd multiplied by 6 to the negative 4th. Remember, negative 4 just means we're going to move it to a denominator. If I'm going to take it out of the denominator, I have to put that negative sign back. Well, let's look at our answers. This doesn't have the negative, which means it's a bad answer. Let's mark it out. This is the only answer that seems to work and make sense. So D there for number 14. All right, last one on the page. These are going fast. Number 15. Which of the following is equivalent for 3 to the 3rd multiplied by 5 to the negative 2nd? All right, well, before I start working through my answer here, let's clean this up a little bit. So we'll have 3 to the 3rd. And notice this is a negative exponent, which means we're going to put it in a denominator. So let's do that. So 5 to the 2nd, there it is. We've gotten rid of the negative sign when we moved it down to the denominator. All right, well, none of my answers seem to match what I see here, so we're probably going to have to keep working. Let's try something. Let's go ahead and take 3 to the third. That's not going to be a very large number. Let's see, 3 times 3 is 9, times 3 more is 27. All right, so my final answer is going to have a 27 up top. Notice we're still having a fraction, so let's try to eliminate some things. A isn't a fraction at all. B is a fraction. We'll hold on to it for the time being. This is a fraction with that 27 there, so let's hold on. Well, that's not a fraction either, so we'll mark D out. So it's something either B or C. Well, let's see. 5 to the second power, that's 25. Well, that's C exactly. So B loses its deposit. C is the only answer that seems to work. All right, this is good. This is good. Next. All right, so scientific notation. So let's see what we can do. It says the Earth is approximately 93 million miles from the Sun. Which of the following expresses the distance from the Earth to the Sun in scientific notation? All right, let's write out 93 million first. So 93, so 1, 2, 3 zeros, that would be 1,000. 1, 2, 3 zeros, that would be million. So 93 million. My decimal's here. I want it there. So 9.3 times 10. Let's see, I passed 3, 6, 7 positions. Which answer matches? Well, first off, C and D, they're not in proper format, so we can ignore them. So it's either A or B. Remember, we said to the 7th power. Sure enough, there's that 7th power with choice B. A loses out. All right, well, let's try number 17. A computer has, what is this, 64.4 times 10 to the third megabytes of memory. A megabyte is 10 to the 6 bytes. Total amount of memory for a computer in bytes can be found using the following expression. There it is. All right, so which of the following represents the number of bytes of memory for this computer? All right, well, let's look at what we've got here. First off, this is all multiplication, which means I can multiply in any order I want. So I'm going to ignore this 64.4 business, and I'm going to focus right here. I've got 10 to the third multiplied by 10 to the third. I can rewrite that as 10 to the 6th, because we're going to add those exponents. Notice we have a common base. So here we are, but that's not proper form. And notice also, none of these are in scientific notation. They're in standard form. All right, well, let's rewrite it. So I'll have a 6, a 4, and a 4. We got to move 6 positions. So 1, so that moves us from here to here. So that's 1, 2, 3, 4, 5, 6. Put our comma here, put our comma there. So I'm looking for, what is this, 64 million. So in other words, 1, 2, 3, 4, 5 zeros. Well, that's only 2 zeros, not enough. 1, 2, 3, 4, 5 zeros. There it is. 1, 2, 3, 4, too many zeros. 1, 2, oh, goodness gracious, another too many zeros. So it has to be B. All right, well, let's try number 18. A beetle weighs, let's see, what is this? 8.7 times 10 to the negative third grams. What is 8.7 times 10 to the negative third when written in standard form? All right, so let's write this down. So we've got 8 and 7. We've got to go 3 positions. Notice it's negative, though, which means I've got to make this number appear smaller than what it is now. Well, notice if I go to the right, it'll make the number appear bigger, so I'm going to have to go left. So we'll go 1, 2, 3 positions over. So my decimal point goes here. So it was here. 1, 2, 3 spots. I'm going to add an extra 0 in front. It's just good form. So let's see what answer seems to match. D doesn't work. Not enough zeros in front. C doesn't work. Not enough zeros in front. A, too many zeros, which means B, notice those 2 zeros, we're good to go. All right. Next, number 19. See, one butterfly egg weighs 10 to the negative 5th grams, so it must be pretty small. A butterfly lays 10 to the 2nd eggs. That's a bunch. See, the total weight of the butterfly's eggs can be found using the following expression. So we've got 10 to the 2nd multiplied by 10 to the negative 5th. What is the total weight of the butterfly eggs? All right, well, let's look. So if I'm multiplying powers with a common base, we'll just simply add the exponents together. So this is 10. Negative 5 plus 2 is negative 3. So there we are, 10 to the negative 3rd power. That would be C. We'll circle it, and all the rest are simply out of luck.